Hello and good morning. At least it's morning here. I want to show you today a real-life example of how project succession is actually already improving production environments. Um, Here you can see the terrain pipeline I'm currently working on. It's still a work in progress. We haven't finished it yet, but uh, what it actually does is it is a visual implementation and a glue in between individual scripts. So as you can see, we have a bunch of little scripts here. This is always cross-platform. Um, and you can also just click on these to see what they do, right? In the end, this one here is calling a GitHub workflow. Um, and why did I do this in scripts and not in nodes? Of course, we could also just do HTTP requests, etc. Um, the thing is, our pipeline existed before project succession, and it's very hard to obviously um, just change everything at once. So for now, it is super useful to be able to also just call little scripts from here and there. Um, that said, a large majority of the workflow in general is already on project succession. So let me actually walk you through this little graph. So when we uh, look at the start. So currently we just start on when as soon as we execute this graph. Um, of course, triggers are interchangeable to a large amount if they don't carry data. That means we could put in anything here, like a cron job, HTTP, like listener or whatever, a webhook. I mean, and then you could basically also just curl the pipeline and it would basically fire based on that. Never mind. So the very first thing is what we do, and which is good practice in general, is to set the pipeline route. I do this by getting in the main script or in the main graph here, I get the working directory and I set this as an environment variable. Why am I doing this? Because then I have a uniform location from where my uh, my whole pipeline can enter. Otherwise, I would need to be aware of that subgraphs are possibly in folders, right? And then if I want to do a working environment from this subgraph, obviously it's in this folder and not on the root. So now I have one environment variable I can put everything relative to. I also then set another environment, which is just a little development branch for, it's hard-coded here currently, just where do I want to publish my changes of this landscape pipeline. And then I set up the Clang environment. Clang is the company I'm working for. It's a little subgraph, we can dive into it. So what we do here is we first get the user home. The user home is a little bit more setup because we want to be cross-platform. So we first get the system info and then the operation system name. If it's Darwin, we know it's a Mac. If it's Windows, we know it's Windows. And if it's Linux, then obviously it's uh, everything else currently is Linux. So if it's not Windows and not Darwin, we know it is indeed a Linux machine. And based on that, we then get the environment variable, either home or user profile, right? Depending on the operating system. And we actually set this as um, as data here, right? So we have the environment variable value, which is the user home, and we have just the string value, which is the system string. Um, we use the system string in later nodes to just quickly find like, hey, what are we on? Otherwise, we would need to do all of this all the time, and we don't want to. So it's basically a setup of some environments too. And yeah, this is what we then do here. We get the system string, and we set this as a system string environment variable. And um, For the user home, we actually get this little JSON file, which is called the AIP. AIP is short for Asset Integration Pipeline. It's a Clang internal thing. We also set the user home as environment, obviously. We read the config. We store the AIP config directly also in an environment. You see how it looks here. It basically has a bunch of locations where what is and how, yeah, what the publishing branch is, how to manage the repositories, if we want to generate code, etc. We find locations for the, out of this config, we also find the locations for all of our repositories we deal with, and we set these as environment variables too. And when this is all done, we know, okay, we have a very convenient way to execute scripts, in this case, in a certain location. So we can just say in a little, in the working directory, we just call env.plastic as a parameter script, and this would like directly default to the environment variable plastic, right, which we did set above. So we can directly say, okay, we want to clean our plastic workspace. The same for, yeah, the same for Git. And then we do something called codegen. Codegen is also like something we do at Clang. It's basically generating a bunch of auto-generated code. And what it does here is basically we get, okay, here in this case, we actually get the system again. And based on if it's Windows, we just say seed codegen. Otherwise, we do this .seed.sh. And based on that, we then have a command which we also execute. So it is very, very simple. And then comes the heavy part, which is actually calling a Houdini process. So we have here our batch cooking scripts, our system string, our Python interface. So here also, again, you see, we use the system string to define what kind of Python interpreter we are using, because on Mac, we're using Python 3. And here we have a resolve path of our working directory, which is the batch cooking directory, which we just set up here, right? Based on our outsource, which we did set earlier. And that's the cool thing about project succession. Everything is visually connected, so you can just like follow the lines. It's not as you need to step through dependencies, etc. In your IDE. So yeah, we then get our map list actually, which is a JSON file. And our interpreter, the map list is basically just a list, hey, what should be cooked? And here we actually find also our hip file we want to cook. It's also just a location. And then we have in the end one large data struct. So we always merge the data together and have our and have basically one struct with all the data we need. This then can be used to execute a script node here. And this manages all the map cooks. For Python API, no need to do manual loops. This is something which we already had, so I didn't see the need to reinvent the wheel. And you see the string here is actually, let me just really quickly create a new file. It's presentation.txt. And if you go there and you see the whole string, I basically get the input value interpreter. Then I execute with this interpreter this little script here, cook map standalone. I define the map list, which is an argument also coming from the input. I define the hip file, also coming from the input, and they define the config, which is also coming from the input. So once this is done, let me go back. Where were we? Here we were. Yeah, once this is executed, I just return the result. I log some output there just to be sure. And if it fails, obviously we throw an error. We then directly execute a second subgraph, and here you see the power of exposed parameters. This subgraph here is used a lot. It's just called execute pipeline script. And you can define like a batch script and a bash script and a working environment. And based on that, it will execute what is right for your environment or like for your operating system. How does this work? Based on the system string we did before, right? Or no, not even. We get the system info, get the operating system name. We either say it's a bash script or a batch script. Yeah, basically the subgraph parameter tells you, like parameter script tells you, hey, this is coming in from an exposed parameter. And based on that, we either use the batch script parameter or the bash script parameter. And then we just join that with our pipeline route and our source. So we go into this folder, we read the script content, and we execute it here in the exposed working directory, and we fail it if the exposed toggle says it should fail. And this is used a lot. So then we do a git operations. We basically pull latest git, and then we do a git checkout branch. Like this is a little bit more custom git stuff. Obviously, we could also do the advanced git operations and do the checkout option. In this case, because I'm quite familiar with this already, so I just used this little script before because yeah, in this case it was even faster than just setting up this node even. And then we execute another script, which is the ensure landscape content. And the ensure landscape content is also super simple. The only reason why we don't call the script directly in project succession, but through a file, is that we want to be operating system independent in this case. So the ensure landscape content basically does nothing else than pull again. Actually, this pull is not needed because we just pulled before. We call this init landscapes, and then we add the content config, which will be modified through this init landscapes. And let me, yeah, here we don't even pull, that's good. And you see, it is super convenient also through this new feature I did just build. You can edit your scripts directly in Project Succession. You also have a console down here where you can just execute commands on the fly, like succession help in this case to get like all the, maybe do succession, maybe status, right? Okay, in this case, because it's a new installation, so we're not getting, we failed to get the cached license, so we get it from the license server, and then we say, okay, it is actually up and running and healthy currently. Yeah, and you can just maximize and minimize this either with a shortcut or through this little toggle here. Yeah, once we have everything set up, we get our map string. So actually, I found a little bug here. We also need to push. Let me just oops, this is also a little bug that need to push. Um, let's maybe use this to be easier to read. Um, yeah, the get map string, what it basically does is it reads in from the batch cooking dir we already have. Um, so in this case, I don't even think we need to redefine this because we already defined it above. Um, I think I did this mostly because we want to be keep our scripts a little bit independent so we can reuse them without too many dependencies. So here we have the data selector, which actually reads in with a JSON parser this little map list file we also had before. And then we do a for loop, which basically tells us, hey, for each of these maps we did just read in, is it set to active? So if the bool is true, then we take its name, otherwise we just continue from the loop. And then we have a list of active map names. We join this list, separated by a comma, and then we have our map list string. Yeah, we actually set this also as an environment variable called landscape, and then we trigger the content build, which is also here. A content build in this case is nothing else than just building the addressables for these landscapes so we can stream them into the game. And this is where I'm currently at. So the next thing is to make a PR and commit all of that. And the cool thing is, once this is set up, it can run autonomously wherever you want, like day and night. You don't need to monitor it, and we can just like say, okay, we want 5 new landscapes, let's set this, and the next cook will automatically pick it up. And that's all set in this map list.json. This is a little bit more complicated, but a real life example on how a production, like a complex production pipeline, could look in project succession. What is the benefit of this versus all the scripts and doing manual GitHub actions, etc.? First, this runs on any machine which has project succession installed, be it like a GitHub worker, be it like your personal workstation, be it like a dedicated machine in the office which just runs and stands there, which is what we do actually. Mm, this is just like super cross platform compatible. Um, Especially if you set it up with the correct scripts and everything, this should work. Um, and the second big benefit is that you have like a very visual output of nodes, of individual working steps. Like each working step is a node, and that makes it easy to trace at what step things break. Um, you also have comprehensive logging, obviously, in your console, although the console is just, yeah, basically what gets caught in the moment. It just displays this. But you also have obviously logs saved to disk. So in the, let me just quickly find the location. Um, yeah, in here we have our logs, and you see here we directly get basically everything which happens logged out. And this is super simple then to debug. So you directly see, okay, this node here, set environment variable, uh, did execute successfully. Okay, in this case, it's just a little, but you could also just search for spams, etc. Right? So this is it. I hope you like it. And don't forget to just check out Project Succession. It is free for non-commercial use, so You don't need to pay anything. You don't need to put in any credit cards, etc. This is purely for experimentation. If you want to go, actually, hey, I want to build my game pipeline with that, and I build something with the intent of releasing something, I would be obviously very happy if you could support me and, yeah, enable me to continue the development of Project Succession. Thanks so much and have a wonderful day. Cheers.